Hello everyone. Today we're gonna keep going with Prim's algorithm. Um, so before we start, actually, a couple of rules about the Prim's algorithm is showing about how to find your minimum spanning tree. So, so start the beginning. What is the Prim's algorithm? It's like a set of the rules that determine the minimum spanning trees for the graph. So we're choosing the vertex. Any vertex can do. Um, Inspect the edges and start from a vertex and choosing one of the lowest weight. So lowest weight is the second step. So if there's two edges and have same weight, then doesn't matter which one you choose. And choose the vertex, start vertex and edge, and it connect to the beginning of the minimum spanning tree. And next part, inspect all edges start from the both of the vertex you have in the tree so far, choosing the edge and the lowest weight, ignoring the edges, and will connect tree back itself. The vertex and edges you already have, plus the actual edge and your vertex are connect to, so from the minimum spanning tree so far, and repeat the process until all vertices are connected. Okay, so I just read the whole steps. So how are we doing in the mathematical way? So I'm gonna show you this example. So we're gonna apply for the Prim's algorithm to find the minimum spanning tree for the graph showing on the right. Write down the total weights and the minimum spanning tree. Okay, first thing first, I'm gonna start with A. So we're going to the F. So start with A, and we're choosing the smallest weight edges from vertex. So A to which one is the smallest? Let's have a look. 2, 5, or 6. Which one is the smallest? Definitely is 2. So we're going to B. So from A to B. And now, what we're going to do is we're choosing the smallest and look at the vertex A and B. The smallest weight edge from either vertex A or vertex B is from A to D. So once we're choosing the B, and then what we're going to do is we're going to B, and then once we finish the B, and we're choosing the smallest one, next one is a 5 because it's going to the next one, to D. So now we have is A, B, and D. The smallest weight is from A, B, and D is from D to C. So which is from D to C. And then we only have the A, B, D, C, and the smallest weight will be C to E. Yeah. And after that, and we had E to the F, which is the smallest. So the graph well looks like this. Graph well looks like A, B, D, and C, and E, and F. So that will be 2, 5, 3, 5, and 2. So the total width of minimum spanning tree, that will be 2 plus 5 plus 3 plus 5 plus 2. So that equal to 17. And so why are we choosing A to B and A to B on both? I will let you know because The smallest weight vertex A is to B, so this is 2. You have to hit in every single vertex. But if you connect from B to C and to B to D is larger than A to D. So that's why I'm choosing the smallest one, A to D. So that's why the 5 is smaller than the 6 and 8. So that's why I'm choosing. So did you see that happening? Hopefully that makes sense. Now you can try this, but we definitely can try in during the class as well. But let's move on to the next part. I'm gonna talk about the Kruskal's verdicts, the algorithm. So what's the Kruskal's algorithm finding the minimum spanning tree? So this one, let's talk about these in the 4 steps. Um, the choosing the age and last weight as starting age, and if there's more than one least weight age, and that will do. And next will be the remaining age and choosing the end age of the least weight, which is a dozen not from the circle. And if there's more than one least, and you will do anything, can be the next age. So repeat the process and all the verdicts are connected, result the minimum spanning tree, and determine the length of the spanning tree for summing the weights of the choosing the verdicts. Okay, same ideas about the same graph. Let's try to with the Kruskal's algorithm and the minimum spanning tree at the ground and to calculate the end lengths. So, start the beginning. What we're gonna do is we're choosing the age out with the least weights. If there's more than one, it doesn't matter which one you choose. And there's 2 ages of the weight 2, which is we can say is A to B and E to the F or F to the E. Um, so we were choosing. So we're choosing A B. So the drawing the showing the A to B. From the remaining ages, which is another one is from E to the F. So both are weight 2. So we're drawing those 2. And then next age we're choosing is C and D because it's 3. So we're choosing C and D. And because the weight of this is 3, so we're choosing C and D. And next one is 5 because 5 is the next one. So we're choosing 2, A to D and C to E. Okay, basically we connect everything. So then we're adding all together 2 plus 2 plus 3 plus 5 plus 5. That equal to 17. So this is the minimum spanning tree to adding the ways of choosing the age. So this is you can see it's much easy way to choosing by the Kruskal's the algorithm. Hopefully that makes sense. And one last thing is called Grady algorithm. So I want you guys to have a look at this one. Okay, the Grady algorithm is simple. So we just try to set up the rules and using the optimization problems. So break up the solutions with that problem as series of simple steps and then find the optimum solution at each step in the process. And so basically they just how we're doing the Grady algorithm, but we can using um, the some examples to show. So find the shortest path of A to the F. So we can say start vertex with 0, which is a nose and circle vertex and new values of 0. So A is starting vertex. And we can say it's signed 0 and a circle. So because there's no circle, so that's 0. Um, And we can say start the vertex A are connected to B and C. So connect B and C, and vertex B is assigned 2, and vertex C is assigned 6. So those two, so we can say vertex B is circled because it's the lowest value. So we say 2, and this is 6. Okay. And now the new circle vertex B is connected to the 3 vertex, which is C and a D, and also E. So we can say starting vertex B is value 2, E is assigned 4. So we can say E are connected 4. Because it's lower than 6, now the two uncircled vertex, which is the lowest one, is a 4, and vertex C and E does not matter which one is circled. Um, so this is a this is called the gradient algorithm. So we just keep continue to circle it. So which connections you between those two. So clearly, if you say the C, you can connect to the A, B, and the D, and that's why we have 4 difference. And D we have 5, so 1, 2, 3, 4, and 5. So which is 5, and this will become to 4. So and so on and so on. And F, so later on, so we can say it's become to 7. So A, B, E, and F, the length is actually 7. So it's good to know with the gradient algorithm, but I will definitely try my best to explain during the class again. So this is my first time touching the gradient algorithm as well. So let me know if you have any question we can discuss together. So basically this is all 8 graph and networks. Hopefully you guys enjoy this, and we're gonna keep doing during the term 2. And I see you guys on Monday.